So we are going to discuss the task 9.3D of SIG 111. This task is about to discuss the hack CPU implementation. Firstly, we are going to discuss the CPU architecture. As you can see in this diagram, CPU consists of many logic gates such as ALU, A register, D register, multiplexer, and PC. As we have studied the logic gates in our previous classes, we can use the concept and understand the implementation of CPU. First of all, we will make the API of CPU, and by abstraction, we will just see the input pin and output pins. Input pins are instruction, enum, reset, and output pins are outem, writem, addressem, and PC. And we will create an API. We will name the chip as CPU. Input pins enum 16, instruction 16, reset, output pins out M16, write M, address M15, PC 15. And implementation of these logic gates, we will discuss it through HDL code, and this is the code. Um, First, we'll look at these two lines. These two lines will determine whether the instruction is A instruction or C instruction. Uh, this is determined with the MSB bit, the leftmost bit of binary syntax. This MSB bit tells if it is A instruction or C instruction. If MSB is 0, it is A instruction. If MSB is 1, it is C instruction. Uh, Same things are here. Um, if it is A instruction, it is a 0. Note 0 is 1, so it's A. But if it is C instruction, it is 1. Note of 1 is 0, and this in A instruction 0, note 1, 1 is C instruction. Basically, these two lines tells if it is A instruction or C instruction. Next is hand A, C instruction, B instruction 5, out AL to A. This is if it is A instruction, C instruction, and sixth bit. This D1. D1, this thing tells if it is A register related. Then it will be ALU to A. Next is selection pin and multiplexer. This will select the pin according so that which instruction should send to A register instruction or ALU out instruction or ALU out. This multiplier decides which instruction will be sent to A register, and this is controlled by control pin, and this control pin is ALU to A. This thing, this one. This selects instruction will go to A register or ALU out will go to A register. If it is register, A, A instruction, it will check it if it's A, then it will load the instruction in A register. After that, if it is A instruction, it will check it is computation related to address or memory, and this will decide with this A. This tells which computation uh, will be there, this one or this one, memory related or address related. This is code that it will be selected by that A and AM out. Next is if decide if that uh, output will load it to D register or not. If the instruction A and B, instruction 4, 1, 2, 3, 4, 5, D2, D2, this thing, it will D register. It will tell if the instruction will be loaded to D register or not, and this is loading of the instruction to D register. Next is ALU part. This is the computation which it calculates the computations x and y. This AM out and D out. ZX, NX, ZY, NY, and F, and NO. These are C1 to C6 pins. C1, 2, 3, 4, 5, 6, 6, 7, 8, 9, 10, 11. This 6 bit is C1 to C6, and outputs of ALU is ALU out, ZR out, and G out. Next, after the calculation compression, it will decide uh, whether the CPU can write on the data memory or not. Uh, as if it is A out is one, the out will be uh, it will write on the address them, mm, this thing. And if ALU out is one out them, this output, and in instruction write them, this pin write them. Then it will check the jump instruction. This is a check if it is equal to 0. This is check if less than 0. This thing check if it is 0 or negative. It should be 0 and negative. And the next is it tells this thing is it is this contains less than equal to 0. It should be 0 and negative. And here it is output will be non-zero positive, or means greater than 0, not equal to 0. And then it is jump if greater than 0, positive instruction 0, or this is less than equal to 0, and this is instruction to jump to register to A register. This line tells it is it to jump to A register. uh, Next is next this, and this line tell um, the load proceeds if this same instruction and the condition of this are met. Condition are meeting, then the instruction will be loaded to PC. But if it is not and no instruction is loaded, the PC will be incremented by 1, and this is the last value which will give the output pin as PC, and this is the PC. So this is the code and basic implementation of CPU. Thank you.